Assistant Professor Urmi Shah from IT/ICT Department of LG Institute of Engineering and Technology. So today we will be moving ahead with the further topics of Telecommunication Engineering subject, and over here we have been continuing with unit number 1, that is Electronic Switching System. So basically in this subject we have learned up till now about what is a switching system, what are the different classifications of switching system, how a switching system functions, what are the different stages of switching system, and in the previous session we learnt about time division space switching and its various networks. So let's move ahead with the topics that we are going to cover in this session. So let's start, or let's understand what are the topics to be covered. So in the previous session we left from the control mechanisms of time division space switching network and remarks on both input and output control mechanism. So that we are going to see in this session. So let's start firstly with the first topic. So basically we discussed in the previous session that control mechanisms include, first topic was cyclic control in synchronism, second was input control, input driven, and third was output control, output driven. So these were the control mechanism which we had discussed in the previous session. Now in this section, let's understand in depth about the control mechanisms. So basically, the control mechanisms include input controlled, input driven. Then the control on the input side works in a cyclic manner. The control on output side is memory based and changes synchronously with the input side. So basically the input side is in synchronism. It is having a cyclic manner mechanism, and that is going to generate the inlet, and based on that the output side is going to save the data which is coming from input side in form of some memory, and that memory is going to have a synchronism mechanism such that it is saving the data one after the other. So that is how the whole synchronism is maintained at input side and output side. Full availability is obtained by using programmable feature of the memory. Programmable feature over here means that if I have a certain amount or certain space memory, and if I want to save lots of data compared to the size of memory, so at that time we need to do programming by having equal allotments of memory to equal amount of data. So that programming is done, and based on that the memory is programmed that for specific data, specific page only will be occupied, and for rest of the data this much space will be occupied. So based on that the data is saved in programmable memory. So programmable feature of memory is used over here to access full availability of memory. So this way control mechanism works. This is the network of time division space switching. As you can see over here, we had a network of n cross n inlets and n outlets. In between the input and output, bus was there. Bus has a role to have storage of the output based on the input coming from the inlet part. So for that circuitry we have clock input. Clock is going to enter into the modulo n counter. Modulo n counter is going to generate the output as you can see over here, and it is going to save it in the memory space as it is shown over here. That memory space is going to forward the data to address decoder. Address decoder is going to save the locations from where the data is coming. Meanwhile, the modulo n counter is going to send the data to 2 raised to k decoder circuitry. This way the whole mechanism works. Nextly, if we are talking about the control mechanism, then it includes programmable memory that we saw in the previous session. The next part is for output controlled control mechanism. It is a dual scheme of input control. The same thing happens at the output side which happened at the input controlling unit. It is a dual part, or it is the replication of the input control part, but it is acting as an output side and input control was at input side. The control on the output side works in a cyclic manner, and over here the control on input side is memory based. So it is exactly the replica of input control. In input control, input side was cyclic and output was having a memory storage or memory based storage which was having a synchronism. While in output control, output side is having a cyclic manner and input is going to have a memory based synchronism. So this way both the processes, input control and output control, are the replica of each other. Here again, full availability is obtained by using the programmable feature of memory. So both the processes are replication of each other. It is almost same, but in input side, whatever input was having the access, that is having the access in output side by the output node. So exactly opposite operations are there. This is the network for output control mechanism. As you can see over here, the circuitry is almost same for the network, having n cross n network with a bus, but the bus structure, as you can see over here, is having the reverse effect. In that, the clock was given the input to modulo n counter, it was passed on to the decoder side. So that was done at input side, but the same process over here is done at the output side. So this way, the two processes in time division space switching network are opposite in input control and in output control. Over here, modulo n counter is passing the data to the decoder circuitry, and via control memory it is going to give it to the decoder, which is going to maintain the addresses of the data from where it is coming. So this is how the difference between output control and input control is there. Now let's move ahead with the next topic, that is remarks on both input control and output control. The switching capacity is equal to the number of inlets and outlets, that is n, both the side. Switching capacity is both the side, n. Inlet is equal to the number of outlets. So n is equal to SC. SC is our switching capacity. The formula we saw in the previous session was 125 divided by TS. Instead of TS, here we will have different time duration, that is TI plus TF plus TD plus TT. Now what are all these time durations? TI is the time to increment the modulo n counter. TM is the time to read the control memory. TD is the time to decode, address and select inlet and outlet. TT is the time to transfer the sample value from inlet to the outlet. As we have discussed in the previous session only, that the clock frequency was 8 kHz. So over here the time duration is 1 by 8k, that is 125 microsecond. That is assumed in the formula. And rest of the times are listed over here, that is time to increment modulo counter, that is TI. Modulo counter increment will be there one after the other data is entering, and TM is the time to read the control memory. Every time for different data we need to have an entry in the memory, and for that we read the data in the memory, so that is the time TM. TD is the time to decode address. whatever data is coming from inlet and outlet, from whichever address or from whichever node, that has to be decoded in the address decoder. So that is that time TD. And what are the sample values that are transferred from inlet side to outlet side? So time taken to have that transfer from inlet to outlet will be measured by time TT. So this is all about the calculation of switching capacity for input control and output control mechanism in time division space switching network. So if any questions come in your examination about how to calculate switching capacity for time division space switching network, and if this time durations have been given to you, you can apply this formula and easily calculate the switching capacity of your network. Okay, let's move ahead with the next topic, that is remarks on input control and output control. That is, here configuration is for bi-direction transfer. Scheme 1 uses two independent buses, one for each direction, and scheme 2 uses one bus and time division multiplexing for two-way transfer. So here folded network kind of structure is used. That is, in scheme 1, if you are having two independent buses means one bus is going to transfer the input and one bus is going to generate the output. That is independent scheme. Second scheme over here is use only single bus. It will be used as a two-way transfer from input side to output side, and from output also it can come to the input side. So it is a kind of full duplex and half duplex communication scheme. So folded network structure can be said over here. Both input controlled and output controlled can be used to support this kind of folded network connection. So that can be used over here. Nextly, this is the network which we saw for time division space switching, but this is the output control network. Output control network, as you can see over here, is having N cross N, that is inlet and outlet, and it's having the bus structure like this. Input will be given to clock to modulo N counter. Modulo N counter will have two outputs. One will go to the decoder, that is the data, and one will go to the control memory. Control memory is going to pass the addresses of the data to the decoder block. So this way the whole process is going to work for output and input control time division space switching network. Now, what are the limitations? So here it is having the limitations on number of subscribers in both input control and output control. All the lines, that is inlet and outlet, are scanned whether they are active or not. The number of subscribers is limited by the time cost of a single speed circuit. It is having non-blocking nature. So this is the limitations of input control and output control circuitry. Following are the references for the topics which we have covered today. See, I told you in the previous sessions that you can refer any of these books for your subject. If you feel that this is a very much theoretical subject, then you can go for last book, that is by technical publication, and if you want to have a detailed understanding, then you can refer book number 1, which is the actual reference book for telecommunication switching system and network by Vishwanathan T. So these are the books, and in the upcoming sessions, whenever we will be advancing with our next chapters, we will be focusing on the network protocols for telecommunication engineering. For that, we will refer second book. So this way, these are the books you can refer for the topics which we have covered up till now. Even we will be having sharing of our notes. Then in the upcoming session, I will be continuing with the last two topics of our chapter number 1, that will include N cross N combinational switching and time division, time switching technique. So that we will be seeing in the upcoming next session. Thank you very much for watching this session. In the upcoming session, we will be continuing with our telecommunication engineering subject. Thank you so much.